Good day. Welcome to this video where we'll be unpacking the product rule as one of the differentiation rules that we have in calculus. Okay, so what do we start with? The definition, and then we go into the application. Right, so by definition, okay, if f and g are differentiable functions, then to get the derivative of the product of f and g, you go f prime of x times g of x plus f of x times g prime of x. Alright, that is basically how the product rule works, and it's also defined in this way. So we need to find the derivative of the first function multiplied by the original function, add, plus the original function times the derivative of the second function. So first term, first derivative, second term, second derivative of the second function. So just for you to be able to remember how it works. Okay, so what are we going to do now? Some examples that pertains to the product rule. Let's go for it. Okay, so here are four different functions that we need to differentiate using the product rule. So let's go for it. The first one, f of x, and see it's a product of two functions. Okay, what do we need? Derivative of the first function, that will be 2x minus 3 multiplied by the original second function, 7x plus pi, plus, keep the first function as it is, the original function, x squared minus 3x. So you differentiate your second function now, you add your second term. Derivative of this guy here will be 7. Okay, so you can leave it like that, no need to multiply out and create an algebraic process there that is totally unnecessary. Okay, good. Let's go to g. G is a product of two functions there, x and the exponential form, or the exponential function e to the 2x. Okay, so this is, f prime of x, and this is g prime of x. So let's go for it. Derivative there is 1 times e to the 2x plus, keep the first function as it is, the derivative of e to the x will be e to 2x times 2, right? Remember we spoke about the in and the outer function in the chain rule, so we apply it there, we differentiate the 2x to get the 2. Here you can clean up, it's very easy to do so, it's e to the 2x plus 2x e to the 2x. Okay, now here we need to find dy over dx. We have sine x as our first function and ln, or the natural logarithmic function, as our second function. Derivative for the sine x here, we get cos x multiplied by ln x minus square, right? Plus, keep the first function as it is, multiplied by the derivative of the natural log, that will be 1 over x minus x squared. But the inner function here is not just x, so it's x minus x squared. When you differentiate that using the chain rule now, you end up with 1 minus 2x. And that becomes the expression that describes the derivative for this function. Okay, here dy over dx, or y prime, will be equal to what? Our first function is the power function, right? The power 100. Second function is x squared. Okay, so let's differentiate the first function using the chain rule here. The outer function is the power function, and the inner function is a linear function. So we go 100 pi x minus 3 to the power 99 times the derivative of the inner function here will be what? Pi. multiply this by our second function, plus keep the first function as it is, pi x minus 3 to the power 100 times the derivative of the the second function, which is 2x. And that is the solution for this one, right? This takes care of the product rule, and in the next video I'll be discussing the quotient rule. So stay tuned and thank you for watching.